All right, so we're going to do two sections again tonight, very similar to what we did Monday. I mean, really, there's not a whole lot of difference, okay, between the two things that we're going to be doing. All right, we're still going to multiply polynomials, and we're still going to do some foiling. These pens often have to be reset. There it goes. Way better than writing with my hands, or my finger anyway. Okay, so multiplying polynomials, still doing the same thing. The only difference in 5-4 is they throw some different variables in there with it. So the idea is still the same. It just gets a little more complicated because you got some x's, you got y's, you got xy, you've got different powers. Okay, so it just gets a little bit more complicated. You got to sort things out. All right, so they actually, I guess maybe I should have called it operations on polynomials because they have some addition and subtraction. So maybe we should start off with that. But it's all going to be simplifying, okay? Like on the test, it's just going to say simplify. All right, so then you just kind of have to decide, okay, what is it asking me to do here? So what do they mean by having so different variables? Well, we could have 5x squared minus 9x squared y plus a 3xy squared. Okay, and then maybe we want to add that to 4x squared plus 3x squared y minus 2xy squared. So when you look at this, it's obvious that these are your like terms between here and here. Okay, this is a 9x squared y, which is different than a 3xy squared because here the y is squared, here the x is squared, so they're different terms. All right, so that's, you got to kind of watch that a little bit. So let me do this here. So we got this one here and this one here. So they're going to combine up to give us 9. So I'm just going to rewrite this 9x squared there. Then we have this one here and this one here. Okay, so we have a negative 9 plus 3. It's going to be a multicolored polynomial. Right, and then we've got this one and this one. So we have a plus 3 minus a 2, so it'd be a plus xy squared. All right. Now these ones kind of have a degree. You can add them up, the powers. So this is 2, this is 3. You get 2 and 1. This is 2 and 1, so that's 3. But I don't really think you get much of an advantage as far as writing it in that order in this case. But you can if you want to switch them around. The other ones most definitely. These ones probably not so much. You can pretty much put them in the whatever order that you want. Like I said, the tough part is just kind of sorting through all the different variables. So if we have a 5 x cubed and a minus 9x squared. And let's go with the x squared y and a minus 4y squared x. Okay, and I'm going to add that, shrink it down just a little bit, plus x squared minus 2x squared y plus 4y x y squared. Okay, so then we just got to sort through all the terms that are alike that we can combine. Okay, so I got a 5x cubed here, right here, but I have no x cubed over here, so we just toss it down there since there's nothing to do with it. Okay, then we have 9x squared here, and I have an x squared here, so we're adding it, so what are we going to get? Yeah, negative 8x squared, good. Okay, then we've got x squared y and another x squared y, so what is that going to turn out to be? Yeah, negative x squared y. Okay, not to be confused with y squared x. Of course, they're different. Let's see. Then we've got a 4 there and a, look at that. They're written differently, but they're still the same, right? Y squared x, x y squared, still the same thing because it's y squared. And what happens to those? They cancel out, so then we don't have to worry about them. All right. What? Oh, I think that's supposed to be a cube. Sorry. That should be a cube because that's what we had here in the front. There we go. More colors. All right. So that's, you're just adding those like terms, combining things. Okay. On the multiplication side, finally we're going to get to that. Is there questions on this part, first of all? Anything? Okay. So we could do one, 4x squared y cubed. Put that in parentheses, and we'll go like this. 5x to the 4th, y to the 5th, like that. Okay? So we're going to multiply these. So we multiply the numbers first. Okay, then think about it. You know, you got x squared, so we got x squared, 2x's, 4x's. What's that going to give us? X to what power would we get there? Well, we got 2, right? And then we got 4 more, so how much is that? 6, yeah. Sure. Just 6. Okay. Same idea. I got y to the 3rd, and y to the 5th. So what's that going to give us? 8, yeah. So all we're doing is adding these exponents up. Again, I got 2x's here, 4x's here. I'm going to combine them so I get 6. Okay, same thing with the y's, 3 and 5. It's the same thing.
So you multiply the number, but add the exponents. You add the like the x squared and x cubed to get x to the 5, but the actual numbers you have, you multiply, right?
Yes.
Okay.
Do you see why the exponents are being added?
I think so. I think I do. Because I think I see.
Right? I mean, that's basically what you have.
Okay.
Okay? And it's all multiplication. See? Times, times.
Oh, yeah, yeah, yeah.
Because that's what a power is. It's just repeated multiplication.
Okay.
So they have some like that. I wonder if they do any. Looking to see if they have. No, I don't see any like that one. Then we have some with an x squared and a y, but now we're going to distribute it. So something along this line. Okay, so now we're just going to take this and distribute it inside, just like we did. You know, again, this is the same exact stuff that we did Monday. It's just got a few more variables in it. Okay, so let's work through this. So we're going to get 3 and 4, so that's going to give us, what are we going to get there? So we're going to get 12x to what power? 4. Y to the 3. Right, because we got 1 here, even though it's not showing that, there's 1 there, 2 there, gives us the 3. Okay, minus, what's this one going to look like? 18x 3y 2 plus 6x squared y. We don't have any x's and y's, so we just kind of carry it with us. All right. And we can check to see if there's anything we can combine, but there's not going to be usually. And there isn't anything there because they're all different terms. All different powers giving us all different terms. Questions on that one? And how we do that? Okay, so then there's some, I think we kind of did some of these already on Monday, but we'll do a couple more here. So something like this. So we have, so we're foiling, so go like that, go like this. All right, so let's do this one first. So what are we going to get there? Yeah, 12x squared, right? And y squared, good. Okay, so now we got that one done, so now we got to go to this one. Negative, just x, y squared, because we don't have an x here to multiply with, so we just kind of have it tag along. Y times y gives us y squared. Okay, now we're going to do this one. Negative 15xy squared, same thing as we just had. And then what are we going to finish this with? What are we going to get here? Okay, so a plus 10 y squared. So now I got, you know, like I said, most of the time you can combine stuff, right, inside here. So does this combine? Yeah, xy squared is xy squared, so that combines. So I'm going to write this one first. And what are we going to get there? 23xy squared. You know, and a lot of people will make mistakes, all right? And what they'll do is they'll say they'll combine this x and make this like an x squared y to the 4th. Because they're adding, so they say, oh, I guess I should add the exponents, you know, because they just get a little bit, because they're just doing so much multiplication that they think that's what they should do, but don't. Okay, so it's xy squared minus 15xy squared gives us 23xy squared. All right, so a lot of times I'll just say, hey, you know, when you get to that point, just read it. And it says negative 8 xy squared minus 15xy squared gives me 23xy squared. All right. That's kind of a tougher one that they're going to give you. They have some more that are kind of like this. Okay, so again, we're still foiling. There, 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 there. So what are we going to get here then? So 3 and 2 are going to give us 6x squared y squared. Good. Okay, so we're multiplying this, so we're going to get x squared y squared like that. Okay. All right, and then we're going to go like this. So 4 and 3, that's going to give us negative 12. But I don't have any variables there, so it's just going to be x, y. Good. Okay, so we got that one done. Now we're going to multiply these two. Plus 4xy. Very good. Okay, now we're going to finish this. Go minus 8. All right, and again, I can combine stuff because about 95% of the time you can. So we start with this, start with this. What are we going to have in the middle there? Yeah, minus 8xy. Very good. All right. Okay. So again, it's not a whole lot different than what we were doing. It's just got a few extra variables in there. They do have some like this, where they're saying, what if we have 3x minus y squared, like that. And do you remember what I said, how to do those? What did I say, how do you attack that one?
Just put it twice.
Yep, write it twice. That's awesome. If you remember that, you'll never get them wrong. Write it twice. Okay, cool. Now we just FOIL, right? So here we go. FOIL, FOIL, FOIL. So what is this going to be? 9x squared, right? So that's that one. Now we're going to reach over here. Minus 3x y. Good. Okay, now we're right here. Minus 3xy again. And you might, some people might say, hey, well, isn't that yx? It doesn't make a lot of difference because it's multiplication is commutative, doesn't matter the order. So if you wrote it yx like this, that's not wrong, it's okay. And then what's our last one over here? Okay. And again, we gotta look in the middle there. Probably gonna combine. Sure enough, even though these are not in the same order, it's still the same term. Okay, so you can combine those. All right, and it doesn't matter whether you write it xy or yx, it's all the same. Okay, it's all the same. It doesn't make any difference. Do you see any ones on 381 or 382 that you're... I'll give you something to work on, obviously, but let's see how far we're going. I don't think there's any fraction ones on there. How about that? That's a rarity. Guy likes fractions. Going up to 75 is the highest number we're doing. Any questions on any of those? Any ones you want to look at?
Can you do number 37?
Sure, do whatever you want. What can you read it to me, son?
37 is negative b, and then parentheses it'll be a squared minus ab plus b squared.
Okay, yeah, I see it now. Okay, so we're going to distribute that inside, right?
Yeah.
Okay, so multiplying these first two, what would that be?
The B and the A
Mm-hmm.
would just be A squared B.
Sure. And again, the order doesn't matter.
Okay.
Okay. So negative a squared b. All right, that sounds good. Okay, now we got to go to this one. I mean, remember, this is a negative b, right? Oops. So what's that going to make this sign here?
Positive.
That's right. It's positive a
B squared.
b squared. Good. Okay, last one. Again, we got a positive and a negative, so and b cubed. Yep, good job. And there, can you combine anything? No. No. A squared b and ab squared are two different things. Done. So they're done. Great. Any other good questions on that? Anything else you want to see? Okay. 5.5. Now that we did all this division, or excuse me, all this multiplication, we're going to do division next. I gave it away. That's what we're going to do next. It's just a tad bit thicker. There we go. Okay, so we're going to do some division. And there's actually a couple different types of division. I don't know when you do the next division. I don't know. I can't remember if it's in this class or it's in 95. I just can't remember exactly where that is. But anyway, so in order to do division, though, we have to go back to those properties or laws of exponents. Okay, so let's review those real quick. And if you've already got it written down, no reason to write it again. So I think I wrote a to the m times a to the n equals a to the m plus n. I believe that's what I wrote. And the next one was a to the m to the n equals a to the m times n. All right. So the next one has to do with division. All right. So in division, if we had 2 to the 4th over 2 to the 6th, all right, then we would have conceptually this idea. And those are going to go away. Okay, so that means we'd be left with 1 on the top and just 2 squared on the bottom. Okay, so that's what's happening in a division situation. And if we flip-flopped it, you know, if it was 3 to the 5th over 3 to the 2nd, then we'd have this over this. These are going to go, and that leaves me with 3 to the 3rd. All right? So basically, what are we doing with these exponents? Canceling out. That is very true. You're canceling out the factors anyway. But we're subtracting those exponents, okay? Now, what we want to be, this one's pretty easy to see. Yeah, I'm going to subtract 5 and 2. Here, we're going to subtract 4 and 6, but if we subtract it 4 minus 6, we get a negative 2, correct? Okay, so actually, one of the laws or properties of exponents says that if you have a number to a negative, then it's going to flip down to the bottom. All right, so, but you're not going to see that. I'm not exactly sure when you see it. I think that's in 95, but I'm not sure. Okay. However, what I would do is just think of it a little bit more like this. I kind of encourage people to think of it more like this than I do with the rule. But again, if you got to have a rule, you know, you got to go with it. So you kind of think of it more as I got 4 here, I got 6 here, So these 4 are going to cancel with these 4, and I get a leftovers of 2. All right, so the actual property says that if I have a to the m over a to the n, then I'm just going to subtract those exponents, okay? But it might be easier for you to think of it more as a cancellation idea, okay? Again, you got to find your way, all right, that you understand it. The other property, oh, by the way, I mean, I can put this one on here, but it should be pretty intuitive that I'm wearing out of variables here. So if I have something like this, then that just means I'm going to multiply this guy and multiply this. Okay, something like that. You can do that and then subtract them. Okay, I don't know if that's even really a property or not. It's just, all it is just a combination of these two, right? It's just saying that this guy's in here. So it's just a combination of these two. So if you want to write 4, you can. That's completely up to you what you want to do there. Another one is if we have a to the 0 power, that's equal to 1. So anything to the 0 power is equal to 1. So if you take your calculator, all right, and you go, let's see, I'll get my calculator here. And I say, okay, I'm going to take 5 to the 0 power. So I got to get my glass so I can see. I don't remember what I have. I have this. I have this XY key 0 equals 1. Okay. 500 to the 0 power equals 1. Anything to the 0 power is always going to be 1. Okay. That's one of the properties of exponents. Okay. If it's to the first power, it's what it is, but 0 power is always going to be 1. Doesn't matter what it is. All right. So let's do some problems now with that. Maybe. I can get this a slide. There we go. All right, so let's try. Again, we're just simplifying here. Okay. So what kind of things are we going to have to do? Well, stuff like this. So if we have x to the 10th over x to the 6th, all right, we can use our properties of exponents. That's who you are. You like that. Or you can think of it as, hey, I got 10 up here and I got 6 down here. 6 of them are going to cancel. That's going to leave me with how many? 4, right? And that 4 is going to be on the top, okay? Because I have more of them on top than I do on the bottom. So it's going to be just x to the 4th. Now, if it was different, so let's say we have, just for kicks, I don't think you're going to have any, but let's say we have 3 here and 7 here, okay? Now, I got 3 on the top and I have 7 on the bottom. So 3 are going to cancel and leave us with how many? 4, but that 4 is going to be on the bottom, okay? So you get something like that. All right.
You want us to answer it like that? 1 over x to the 4th power?
I do, because that's the right answer. Okay? Yeah. Because, and you know, of course, what's happening here is this, it's just like a fraction, right? So if you have 3/9, okay, that reduces to 1/3, right? Because 3 goes into 3 once and 3 goes into 9. 3. It's the same principle. Okay? Yeah. You got to have a 1 up there. Okay? I don't think you're going to have any of those. I really don't, because I just don't think that shows up until later on. But, you know, I wanted to, it's good. What the heck, I'll mention it, and then you'll see it. And, okay. Then they give you a lot of problems to this, not a lot. They give you some problems to the 0 power. Okay. So like -4 to the 0 power. Okay. My thinking is that if you look that one up in the back of the book, they probably say that's -1. Because I think what they're saying is we're going to take 4 to the 0 power and then we're going to make that answer negative, versus what we were talking about before when Aaron was asking me, hey, what's the difference between this guy and this one? Okay, so I think if you have one like that, you're looking in the back of the book, and it's probably going to say -1. All right, it might make a liar out of me, I don't know, but I can tell you that this is the proper answer. Okay. So anything to the 0 power is 1. Again, you got to be a little bit careful. They're going to have some. I see a couple here like this. Okay. Now, 50 is not to the 0 power. Y is. So this is 1. Then we got to take 1 times 50. All right. There's no parentheses around the whole thing. Only y is to the 0 power. So then we would just say, hey, that's going to be 50. All right. But anything to the 0 power is 1. Okay. How we so far so good? Okay. Same idea here. They're going to give you something like this. Okay, so if we have x over 3 to the third, all right, conceptually that means we're going to have x over 3, x over 3, x over 3, 3 times. So if we think of it that way, that would give us this. 3 to the third is 27. Okay. If you want to use your properties of exponents, then it was like that one I was telling you about, where this 3 is going to go here, this 3 is going to go there. So it's going to be x to the third over the 3 to the third, or x to the third over 27. Okay. Either way you think of it, you can think it, however you want to think of it to get it right. Okay, but the second one there would be using the properties. I think that was like number 4, kinda. Okay. Same thing here. So if we have something like this, okay, again, what we're doing, this thing here, 3 times, or you can think of it as bringing the 3 to each one of these, right? So if you think of it as writing it out, we're going to get -2 to the third. We're going to get x. What power would that be on that x right there? It's going to be 12. Very good, because you're going to have 4, 4, 4. We're adding all those up. And then here, we'll have y squared, y squared, y squared, 6. Okay. And you should probably work with this. So that's going to be -8, x to the 12th, y to the 6th. Okay. X and y can't be reduced. I've seen people do it though. All right, but don't, because they're 2 different terms. So you can't reduce these. All right. Okay, don't do it.
So which one, would you accept both, or do you have to, because that's -8x?
Well, if I'm not going to be real petty on something like that, okay?
Okay.
But are you taking more math classes?
Down the road, yeah.
Okay. Another guy might be. All right. So, my philosophy is I'm assessing you on whether you understand what this means. Okay.
Mhm.
So if you're telling me this is -2 to the third, you're telling me basically that you're getting it right. You understand it.
Mhm.
Okay. But somebody else might say, no, you're going to take 2 to the 8th. So I guess I would just do it, just so you get in that good habit, so that when your next math teacher doesn't, dock you on it. Okay. Let's see here. Let's see. There's some more stuff here. I know we're kind of going at this a little bit. These are just all kind of the same idea. But I guess it's okay to do them. I just don't see any with the denominator one small or bigger. So you're kind of looking out there. Okay, so let's do this one here, and then I'll give you a little break, and we'll come back and look at the final division ones, and then we'll do some problems. So let's do this. So here, okay, we want to treat each one of these, right? So we can reduce this guy. Okay, so let's reduce that 12 over 10. What's that going to reduce to?
Can be 6 over 5.
Yep. Okay. All right. And make sure now that if it says simplify and you don't reduce it, that would be wrong. Okay. So you want to make sure that that should be simplified, because it's not if you don't reduce it. So we have x to the 9th, x to the 7th, so that's going to give us x to the what? Yeah, how many x's do we have up here? 9 in here. So 7 are going to go away, leave us with on the top. Okay, 9 minus 7 is 2. If you're doing the law, that's what it says. Property of exponent says that. Let's see, then what about our y here? What are we going to have here? Okay, we're going to have a 3 on the top. 4 minus 1 gives us 3, or 4 y's, cancel out with 1 y, gives us 3 leftovers. Okay, there's your answer. Okay. Do you want another one like that one? Okay. 20 over, here let's go 20x to the 6th, 15 y cubed x y 9. Okay, here we go. I flip things around a little bit, try to make it a little more challenging. So we got 20 over 15, that's what we do first. What does that reduce to? 4 over 3. Okay. Alright, if somebody started out math 20, you do, gosh, fractions, you spend like months on that stuff. X, we got an x to the 6th here. We got x to the 1st here, right? So 6 and then 1 on the bottom is going to give us what? How many x's? 5, very good. Okay. Then we got 9 here, 3 here, 6. Okay. So exponents are a little tricky. I mean, I'm not going to, they're a little bit tricky, especially when they get negative, but you don't, I don't think you do that till Math 95. All right. So,
5, 6.
huh?
I think maybe in 5, 6 it does that.
Oh yeah. How about that? I was wrong. I knew it comes up. I just couldn't remember when. Okay, that's when it gets a little tricky. It's when they're negative exponents. I forgot that was in their scientific notation. Okay. Maybe we just hang in here for a little bit more. So after we get all that, the final stuff that we need to know tonight is just something like this. Okay. All right. So this is a division. Okay, but it's all simplify. Doesn't change. So how you're going to divide this is you're going to take this number into each one of these numbers. Okay. So you have to divide it into each one. And the reason for that is because this can be rewritten as this. Okay. okay? When you have a bar over a whole thing like that, then that means that each one of those parts is divided, okay? So that's why you have to take 3 into the 6, 3 into the 12, and 3 into the 9. Now you can't do anything else, so you just divide it, all right? And every problem should be done that way, all right? So in other words, this number should be able to go into each one of these things, okay? If it doesn't, then there's something up, okay? So what happens if we have, say, something like this? All right, so let's say we got something like this. This is probably one of the toughest ones that would be there. All right, again, we want to divide that into each one, okay? This is going to go into each one. All right. So 3 is going to go into 24. I know that's 8. But I have an x squared and an x to the 4th. Okay? So I got to do that same thing that I was just doing. I got 4 x's here and 2 here. So what's that going to leave me with? X to the 2nd minus 12 divided by 3. Well, I know that's 4. I got 3 x's here and 2 here, so it's going to leave me with 1. Good. 3 goes into 18, 6. X squared over x squared, they're gone. So there's your answer. All right? But it has to go into all 3 of those terms. Okay? All 3 of those. If it doesn't, then you can't really divide it. Okay? So that's the end of 5-4. So we did 5-3 and 5-4. Okay? So I'll do the exact same thing we did on Monday. Okay? I'll go through this. I'll put some problems on here. You can go, but go take a break. Come back in about 5-10 minutes or so. I'll have some problems up here for us to work through. We'll work through some of them, and then we'll go from there, I guess. See what we got here.